Hello and welcome everyone on the Transport, Telecommunication and Energy of PECB webinars. My name is Mustafa Bislimi, the PECB organizer of this webinar, and today's topic is improvement on energy performance according to the ISO 50001. Continual improvement in energy performance is the ultimate goal of implementing an ISO 50001 energy management system. In order to achieve it, organizations need to look closely at their specific operation, which will be elaborated more in the online webinar which will be hosted today by PCB trainer Mr. Tariq Khan, who has more than 20 years of experience in multiple fields of ISO standards in general. Please write your questions and comments in the question box in the right-hand control panel, and Mr. Tariq will answer to them accordingly. Please, Tariq, you may start the presentation.
Hi everyone, this is Tariq Khan. Well, we are talking about on PECB's webinar on improvement on energy performance. But before that, I would like to tell you a little about the management system. The requirements are the general requirements, management responsibility, energy policy, planning, implementation and operation, checking, management review. In little detail about that, the organization, they shall have established document implementation, implement, maintain, and improve in according with the requirement of this international standard. Define the document, the scope, and the boundaries of its environment, as well as the energy management system. Determine how it meets the requirement of the international standard in order to achieve continual improvement of its energy performance and its energy. The management responsibilities, the top management or its representative when communicating to those in the organization can support the importance of energy management system through employee involvement activities such as empowerment, motivation, recognition, training, and rewards and participation. Management representative, which he has to perform, the management representative may be current, new, management representative may represent all or part of the job function. Skills and competencies can be determined as to an organization size, culture, and complexity, or to legal requirement or other requirement. The energy policies are there for all standards. So did this, and the requirements is appropriate to the nature and scale of the organization's energy use and consumption. Commitment to continual improvement in energy performance includes a commitment to ensure the availability of information and the requirement to which organization subscribe related to its energy use, consumption, and efficiency. Provide the framework for setting the review energy objective and targets. Support the purchase of energy efficient product and service, and design for energy performance improvement. The documented and communicated at all levels within the organization regularly reviewed and update necessary. Energy planning. The major points for this clause are legal requirement and other requirement, energy review, energy baseline, energy performance indicators, energy objectives, energy targets, energy management action plans. Implementation and operation clauses are competence, training, awareness, communication, documentation, operational control, design, procurement of energy services, product, equipment, and energy. Checking, monitoring and monitoring, measurement and analysis, evaluation of compliance with legal requirement and other requirement, internal audit of energy management system. And corrective action and preventive action. And last is control of records. Management review. This is the most important also. Input to management review, output of the management review. Well, we come to the today's course main point, that is improvement on energy performance. Improvement on energy performance is continual improvement on energy performance is the ultimate goal of implementing ISO 50000. In order to achieve it, organizations need to look closely at their specific operation for manufacturing sector and significant amount of energy it's consumed by hardware installations. Since their operation involve different type of production machines, equipment, and auxiliary devices. With the advancement of technologies, production machine and auxiliary equipment with high energy efficiency are available in the market, then that can help reduce energy consumption and achieve cost saving. There are also quite a number of practical energy saving measures and techniques applicable to various industrial applications. Organizations should consideration when improving their energy performance. Energy saving best practice. Regardless of practices and measures that can be applied by the industries to enhance energy performance. In contrast to some people believe many of these best practice does not necessarily involve much investment, yet bring noticeable improvement in energy performance. Causes illusion of energy saving technologies applicable to general industries. Well, I have 5 cases on that. I'll tell you each one of them. The case 1 is regarding energy saving device for diesel power generation to achieve complete. Number 2 is value speed drive in central chilled water pumps. Number 3 is use of light emitting Diodes LEDs to replace traditional fluorescent tubes. Adjustment of room temperature setting of air conditioning system. The 5th one is regular maintenance and cleaning of air filters. Okay, the first one is the energy saving devices for diesel power generator to achieve complete. The problem is in recent year, due to many grid power shortage, some manufacturing facilities face the challenge in the intermittent power suspension from time to time. During this time of power suspension, factories usually rely on its own diesel power generation to supply electricity for production. Operating diesel power generators require burning of large quantity of diesel, which may result in complete combustion of diesel and thus lower its energy efficiency. The solution for this case, the energy saving device for diesel power generation, helps enhance fuel quality through breaking down of large incombustible practical particles so as to achieve full combustion of diesel fuel. Equipped with advanced technology from overseas, this device can create a strong magnetic field of about 30,000 gases to generate strong attraction and repulsion force to continuously when diesel passes through the strong magnetic field. Larger particle can be broke down to no more than 0.03 millimeter in size, which can be fully burned. Removal of large incombustible particles that would have otherwise been released to the environment can also help reduce dust deposition inside the combustion chamber and reduce fuel consumption of the diesel power generator. Cost effective. This device can save about 15 to 13% of diesel consumption and save consumption, and the average payback period is estimated time is about 1 year. I hope this will help. Okay, the case number 2, variable speed drive in the central chilled water pumps. In general, the problem is in general, the total cooling capacity of central air conditioning system is designed according to the highest cooling load plus an amount of spare capacity. However, in actual operations, sorry for slide moving. However, in actual operation, the cooling demands does not usually reach the highest load in most of the operating time. As a result, the energy consumption of the air conditioning system is always higher than the actual demand. For example, large amount of energy is wasted. The solution for this problem is variable speed drive (VSD) can be installed for chiller water pumps together with a control software to optimize the operation parameters of the air conditioning system, such as loading capacity and coefficient of performance. With the installation of VSD, the cooling demand can be satisfied while the operation of the air conditioning system can be maintained efficient at all time. For example, when the factory temperature is high, the VSD will allow a higher chilled water flow to increase the speed of the water pumps, and vice versa. During the night time, both the production activities and the number of workers in the factory are reduced. Only minimal cooling power is required. The VSD can regulate the chilled water flow rate according to these fluctuations in actual demand in order to maximize the operation efficiency and achieve energy savings. The cost effectiveness. The VSD can save about 53 to 81% electricity consumption, and payback period is estimated is about 3 months to about quarter to 2 years. Case 3. Use light emitted diodes, LEDs, to replace traditional fluorescent light. The problem: production process in factory is usually labor intensive. Energy consumption of light is usually around 10 to 15% of total energy consumption of the factory. The solution for this: as new generation of lighting technology, LED, contain electroluminescent material on a chip packaged with metal wireless for connection and encapsulated with the lens and silicon for protection. As a result, LED has good shock resistance. LED is solid-state cool light source, which provides a high luminous efficiency and can convert around 80 to 90% of electricity to visible light. As comparison, the luminous efficiency of traditional incandescent light bulb is about 20%. LED can also provide a longer service life. The cost effectiveness. Use of LED to replace with traditional fluorescent tube can save about 30 to 76% of energy consumption. The payback period is around 1 to 2 years. Okay, the case number 4. Adjustment of room temperature. Setting of air conditioning system. The problem is indoor is always too cold in summer because the room temperature setting is too low. The solution for this: monitoring room temperature continuously and adjusted the thermostat to the reasonable temperature, says 25 degrees Celsius, or replace the thermostat if it is not functional. Every increment of 1 degree Celsius of the room temperature can save approximately 1.5% energy of the air conditioning system per year without sacrificing occupant thermocomfort. The room temperature should be set higher as far as possible. The energy saving is around 2 to 10% by setting up the thermostat up to 25 degrees Celsius. Okay, the last case: regular maintenance and cleaning of air filters. The problem: filter in air conditioning system can reduce dust, particles, matters circulation with the indoor environment. However, after operation of certain period, dust will accumulate on the air filter to increase the pressure drop and hence increase the energy consumption of all fans. The solution for this: clean regularly all filters of the air conditioning system that cannot
only save energy due to the air fans. Okay. Due to the air fans, but also improve indoor air quality. The cost effectiveness: cleaning of air filters can usually save 5 to 20% fan power. Okay, furthermore, we have energy saving techniques applicable to a specific industry. Now here we are talking about the specific industry where we are involved in or visited. The investment payback period may vary, depend on the different technologies, equipment brand, operation capacity, and other technical and financial factor. Therefore, the estimation provided here is for reference only. Readers are advised to get more technical and financial information from the suppliers for detailed evaluation. Energy saving technology is applicable to specific industries. Different industry sectors have their own specific production processes involving different energy consumption processes. Therefore, specific saving measures and technologies should be applied to these sectors to reduce energy consumption. Some cases illustrated to the energy saving technologies applicable to specific industries. We have identified this one according to the estimated payback period. So every industry concern or people will know by their specific industry and within which span of time they can recover by that amount. Okay, I have 10 cases. The first one is from electronics industry. So I'll go with the case on directly. Okay, high frequency switch mode power supply. The industry is electronics. The problem is currently traditional silicon controlled rectifier is commonly adopted as power supply in electro plant process. However, this kind of power supply system has many drawbacks of large in volume, high copper, less and edgy current problems. As a result, electricity conversion efficiency is low and lifespan is short. The solution for this: high frequency switching mode power supply can integrate a metal oxide semiconductor field effective transistor as a switch element of electronic circuit. Together with microcontrol technology, the power supply can be operated under high frequency of 10 kHz to 50 kHz. This operating frequency not only enhance electric conversion efficiency but also reduce copper loss of the electroplating process. The copper consumption of by using this technology is only 30% of that by using traditional technology. Furthermore, this technology can reduce energy loss due to eddy current. Due to its fast response in order to microsecond. This technology can enhance power output suitability when the power grid experiences unstable condition. In addition, The waves from the power output can be adjusted according to the specific requirement to the suit different process. The heat generation of power supply using this technology also decrease due to reduce power loss. The cost effectiveness of this technology can reduce energy consumption by around 25 to 30% compared to traditional silicon controlled reflector power supply. The payback period for this technology is around 2 to 3 years. Okay, the case number 2 is from electrical product and equipment, and technology description is stamping machine with variable speed drive. Stamping machine, the problem is the stamping machine is one of the most commonly used production equipment in electrical products and equipment industry, and usually consume a significant amount of energy. Even when it's not in operation, the electric motor of the stamping machine will normally keep running at the unloaded mode. Since power factor of the machine tends to be low when the machine is operated with no or light load, energy wastage will be resulted during such operational conditions. The solution for this: if a stamping machine is equipped with the variable speed drive, the energy output will be automatically adjusted according to the actual loading. Thus, the energy wastage is unloaded and loaded operating conditions can be minimized. The cost effectiveness. Amount of actual energy saving depends on the operating time for unloaded, light loaded, and fully loaded conditions. The longer operating time for an unloaded or lightly loaded status, the more energy can potentially be saved with this technology. The payback period for this estimated is about 3 to 4 years. The third one is from textile industry. Recovery of steam heat and condensate from the ironing process. Problem: the residual steam generated from the ironing process in textile factories used to be discharged into environment directly. It wastes a significant amount of heat, energy, and water resource. The solution for this: after installing a steam recovery system, residual steam can be recovered to heat up the water for hot water supply in dormitory to replace the gas-fired boiler, oil-fired steam boiler, or electric boiler. Residual steam is collected from the production line by using pipes through heat exchange. Fresh water can be heated up for the employees to use. When the water temperature difference between the dormitory water storage tank and steam recovery system exceed per set threshold value, the dormitory water will be pumped into the recovery system to absorb thermal energy and then return back to the dormitory wastage storage tank. This circulating process repeats until the difference in water temperature difference is reduced to the preset value. The water temperature in the recovery system is about 70 to 90 degrees Celsius. The steam recovery system is effectively recover residual heat of steaming and minimizing heat loss to the environment. It also help to save energy consumption for heating up dormitory waters. The cost effectiveness. Annual cost saving range from $3,500 to $10,000. The payback period is from 3 months to 3 to 7 months. The next case is also from textile. Retrofitting of savior motor to saving machine. The problem is traditional saving machine is usually equipped with the clutch motor. When traditional motor are in idle mode, the electric current that supplies the motor is still maintained at high level, and thus loss of electricity energy is wasted. Furthermore, traditional motors generate much noise which may affect the productivity of factory staff. The solution of this is servo motor is often the execution component of an automatic control system when receiving control signal for action. The servo motor will rotate and generate regular velocity or speed as output. When the control sign diminish, the motor speed decrease gradually before it stops. The rotation speed and operating current of a servo motor normally controlled by a microprocessor. By adjusting the electric current, the servo motor can achieve the desired working speed. During the initial idle mode, the servo motor requires less electric current and rotate with lower speed than traditional clutch motors. When in operation, the electric current will go and up and down depend on the motor speed. The other solution is compare with the traditional counterpart. Sewing machine equipped with a servo motor will generally consume less energy during the breaks between sewing motion. Servo motors are also quieter than clutch motors. Furthermore, since there are no moving parts in the control, the lifespan of servo motor is also longer. The cost effectiveness. Energy saving is about 50 to 80% for sewing machine equipped with servo motor compared with its traditional counterpart. The payback period is around 2 to 5 years. Okay, the case 5 is from plastic product and printing. Recovery of steam heat concentrate from the production line. In general, The problem is, in general, steam required in the production line is provided by a coal-fired steam boiler. During the production process, a significant amount of steam is released to the environment. The solution for this, the residual steam will be collected and compressed by the steam recovery system for heating up water. The condensate will be circulated back to the steam boiler for reuse. This system not only recovers a large amount of steam heat but also recycle the steam condensate to the boiler steam. As a result, freshwater supply which is required by the boiler system can be reduced. The cost effectiveness. Due to the saving of significant amount of water and coal consumption with the application of this system, the payback period range from 9 months to 2 years based on the actual industrial application. The case number 6 is also from paper and product printing. Fully automatic standby power management system. The problem is factories may face grid power supply interruption or shutdown. In a short notice, under such circumstances, in all production line must be paused and the organization has to use its own diesel generation power supply to resume the operation of the production line. This practice will result in extra production time to the production, which may cause economical loss. The solution for this, the fully automatic standby power management system is able to control different source of power supply by using microcomputer program. It's allow automatic power switching without interrupting to the power to the output power supply. This system can also allow automatic voltage and loading monitoring during the switching of power supply between utility grid and generators. It connects with the individual power generators and optimize their operations to allow fuel saving. The cost effectiveness, as per the operation time of a standby generator is reduced. The consumption of fuel and corresponding air pollutions generated due to the combustion of fuel are also reduced. The payback period is estimated to be around 3 to 6 years. Oops. Okay, the case number 7. It is from metal products. Regenerative waste heat recovery system for melting furnace. The major heat loss from metal melting and refinery is the hot exhaust gas through flue. The temperature of flue exhaust may be higher than 450 degrees Celsius.
Some factories have installed a traditional heat recovery system on the melting furnace to recover the heat exhaust, but the recovery efficiency is not very satisfactory, requiring longer time for preheating and combustion. This setup may also affect production volume and increase defective rate. The solution for this: regenerative waste heat recovery system can be used to replace the traditional heat recovery device. There are two independent heat recovery chambers full of regenerative balls which can be absorb more residual heat from the flue exhaust effectively and enhance the ambient temperature of the chamber. Then it can help further preheat the fresh air. For combustion is interchangeably changeably through this way the heat recovery efficiency is more higher compared with the the traditional heat recovery device. As a result, more residual heat can be recovered and time for preheating fresh air can be shortened and energy saving can be achieved. The cost effectiveness for this energy saving efficiency is about 15 to 20% for melting furnace equipped with the regenerative waste heat recovery system compared with its traditional counterpart with the traditional heat recovery system. The payback period for this is about 8 months. Case number 8. It is also from metal products. Addition of low temperature decreasing powder in degreasing solvent. The problem is in the past decreasing solvent tank was required to heat up to 60 to 80 degree Celsius to enhance the degreasing efficiency. Heating up and maintaining the degreasing tank at high temperature consumes significant electrical power. The solution for this is, in order to save energy consumption, low temperature degreasing powder can be added into the degreasing solvent tank. After applying this powder, the degreasing solvent tank can maintain similar degreasing effectiveness at room temperature, that is 30 to 40 degrees Celsius. As a result, it is only need to heat up degreasing solvent in the winter, and hence energy use for degreasing process can be reduced. The cost effectiveness is energy consumption is reduced by 81% from degreasing the solvent tank with use of low temperature degreasing powder compared with its traditional counterpart with low temperature degreasing powder. Cost saving is more than $10,000 within a year. The case number 9 is from plastic and rubber products industry. Adoption of ozone filtration system for the water cooling tower of plastic injection molding machine water cooling tower. The problem is the plastic injection molding machine cooling system is for cooling down high temperature machine oil to avoid overheating, which can lead to machine malfunctioning. Factories usually use cooling towers in this cooling process. However, when operated for a long time, the growth of bacteria and mosses in the cooling water will cause deposition of a scale on the heat exchange, which reduce its efficiency. The solution for this, an ozone filtration system can be installed for the cooling tower system to kill bacteria and mosses such that scale disposition on the heat exchange can be minimized to maintain high heat exchange efficiency. This technology utilizes the high oxidation potential of ozone to kill bacteria and mosses in the cooling water, to slow down the scale disposition and to help loosen up accumulated organic and biotic scale material. This residual scale material will then be removed by the filtration system to keep the cooling water clean. As a result, with the heat exchange efficiency of the cooling tower and maintain even after operating for a long time. Furthermore, the ozone filtration system helps enhance the cooling rate of the plastic molding machine as the heat exchanger efficiency of cooling tower has to be increased. Also, the overheating of plastic injection molding machine can be avoided so as to lower product defective rate. The heat exchange efficiency has been enhanced by 70% for plastic injection molding machine water cooling tower equipped with ozone filtration system compared with the traditional counterpart without ozone filtration system. It refers to a cost saving of more plus minus $4,000 per year. The payback period for this about almost 3 years. The last case which I have is also from plastic and rubber products industry. Using energy efficient induction heating coil for plastic injection machine. The problem is traditionally the barrel tubes of plastic injection machine are heated up by the residence heater coils around the barrel tube by conduction. A large amount of heat is lost from the surface of the tube to the ambient air, which also increase the ambient temperature of workshop. Oops. Sorry guys, I normally forget to move page. Fine. The solution for this, induction heating can be applied for plastic injection machine barrel tube heating. This technology uses induction to convert electricity to heat. The major component for this for the system include magnetic coil, a converter, a coil, a control box, and production shield. The converter will convert AC current into DC current and subsequently generate electric current with the high frequency. When such current passes through the magnetic coil outside the tube, eddy current is induced inside the metal tube indicators. As a result, heat is generated at the metal tube, which heat up the plastic inside the tube. With this technology, the heat coils do not need to be heated up while the heat generating the metal tube will installed to minimize the heat loss. Furthermore, this technology enables faster and more even heating to barrel tube. In short, this induction heating applies not only saving energy consumption of plastic injection machine, but also produce less heat to ambient temperature of the workshop and hence reduce air conditioning demands. The cost effectiveness for this will be electrical energy saving of this technology is around 35 to 65 for plastic injection molding machine equipped with the heating coil compared with the traditional counterpart with the resonance heater coil. The payback period for this 1 to 4 years. There are others also, but at this time we have till here, which most frequently visited by me on audit. So thank you very much, and Mr. Mustafa.
Thank you. Thank you very much, Mr. Tariq, for this great presentation. And at the same time, I would like also to thank the attendees also for joining us. We hope you enjoyed this webinar. Yeah, we have received all the questions, and because today the time is limited, we will answer them individually by email. We invite at the same time for the next webinar on the topic differences between ISO 29001 oil and gas and ISO 9001 quality management. Thank you very much, everyone, and wish you a wonderful day. Bye.